Good morning, friends. This new course is about the progressions, and we are going to start the introduction part in this first section. First is the sequence, the definition. A sequence is a function whose domain is a set of natural numbers. If the codomain is a set of real numbers or complex numbers, then it is called the real sequence or complex sequence respectively. So if I am having the function f and its domain is the set of natural numbers, and if the codomain is, this is your domain and this is the codomain, and if the codomain is a set of real numbers, then the sequence is the function that is called the real sequence. And if the codomain is a set of complex numbers, then we say that the sequence is the complex sequence. Suppose I am having a function from the set of natural numbers to the set of complex numbers. We usually denote it by f1, f2, f3, so on, and is equal to the value of the function at the point 1, 2, 3, that gives the value equal to fn. And if I take fn to be equal to tn, suppose, then this sequence can be written as t1 for n equal to 1, this, t2 for n equal to 2, this one, t3 up to so on, right? Next is the arithmetic sequence. A sequence of numbers tn is said to be in arithmetic progression, that is AP, when the difference, that is tn minus 1, the previous term, when this difference is constant for all n which is belonging to the set of natural numbers. So this constant is called the common difference. Very fine. Okay, so this constant is called the common difference of AP, the arithmetic progression, right? So if I take the common difference, that is denoted by D, is equal to tn minus 1. If the first term of the arithmetic progression is taken as a and the common difference to be d, then the nth term tn, that will be equal to a plus n minus 1 into d, where a is the first term, n is the number of terms, and d is the common difference, right? If you want to calculate the first term, that is t1, then you have to take n to be equal to 1 over here. For the second term t2, you take n equal to 2. Similarly for the other terms, right? Okay. Then is the sum of the first n terms of AP, that is denoted by Sn. So that can be calculated as n divided by 2 into twice of a plus n minus 1 into d. That is equal to n divided by 2 into a plus l. A is the first term and l is the last term. That is the nth term of AP. You can calculate the sum either from this or from this. Next, what are the results we can get from the arithmetic progression? If fixed number is added or subtracted to each term of AP, then the resulting sequence is also an AP. So if I am having the AP sequence to be T1, T2, T3, so on. If I add any number over here, suppose if I add 2 to each of the terms, then this resulting sequence is also the AP sequence. Similarly, if you subtract the fixed number from each of the terms of AP, then the resulting sequence is also an AP. and it has same common difference as that of the given AP, right? The common difference is same. Second, if each term of an AP is multiplied by a fixed constant or divided by a non-zero fixed constant, then resulting sequence is also an AP. Then is, if A1, A2, A3, A4, these are in AP, and B1, B2, B3, B4, this is also in AP, then their sum A1 plus B1, and the second term A2 plus B2, and the third term A3 plus B3, and so on. This is also is an AP, right? Then is, if it is needed to consider the three terms of AP sequence, then you have to take those three terms to be A minus D, and A plus D. In this way you have to take the three terms in AP, right? And if you want to consider the four terms in AP, then you have to take A minus D, A plus D, A plus 3D, and here A minus 3D. Please consider these terms when you want to take the four terms from AP. Then sum of the identities. The sum of the natural numbers is equal to n into n plus 1 divided by 2. Sum of the squares of the natural numbers is equal to n into n plus 1 into 2n plus 1 divided by 6. Sum of the cubes of the natural numbers is n into n plus 1 divided by 2 whole square. That is the square of this. Then is the arithmetic mean of any two numbers A and B. An arithmetic mean is denoted by A. So that will be equal to the sum of the numbers divided by 2. And for n numbers, you have to take the sum of the numbers A1, A2, A3 up to An divided by n. So this is how we calculate the arithmetic mean. And now the next topic is geometric progression. A sequence is said to be GP, that is the geometric progression, when its first term is non-zero and each of its succeeding terms is r times the preceding terms. R is some fixed non-zero number, that is the common ratio. And it is clear from the definition that no term of GP is 0. The first term is non-zero and the succeeding term is r times the preceding terms. So there should be no zero term in this sequence. Then if I consider the first term to be A and the common ratio to be r, then the nth term Tn is calculated as A into r the power n minus 1. N is the number of terms. And the sum of the first n terms is equal to A into r the power n minus 1 divided by r minus 1 if r is not equal to 1 and is equal to n times A if r is equal to 1. So this sum is for these two cases. For r, if x is greater than minus 1 and less than 1, then the limit n tends to infinity, x the power n is equal to 0. This is very important result. Please note this. And sum of the infinite GP, that is 1 plus x square so on, that will be equal to 1 divided by 1 minus x. Please note this also, very important. If r is strictly greater than minus 1 and less than 1, then sum of the infinite GP a plus ar square up to so on is equal to a divided by 1 minus r. This is very important. So these are the few results or remarks which can be taken as very important note, where we calculate the sum of the GP, the infinite GP or the finite terms. The infinite GP or for the finite terms, right? Next is the other results. If each term of a GP is multiplied or divided by a fixed non-zero constant, then the resulting sequence is also a GP. If A1, A2, A3, A4 is in GP, B1, B2, B3, B4 is also in GP, then their product A1, B1, A2, B2, A3, B3 is also in GP, right? Then is the geometric mean of two numbers a and b is equal to the square root of their product. And if I am having n numbers, then the geometric mean is equal to the product of these numbers, the power 1 by n, right? Then if you need to consider three terms in GP, then you have to consider the terms to be a divided by r, and a into r. And if you need to consider four terms in GP, then that should be taken as a into r, a divided by r, a into r cube, and a divided by r cube. Very important. Then is the harmonic progression. The sequence a1, a2, a3 up to an, where ai is non-zero for each I, is said to be in harmonic progression, that is HP. If the sequence 1 divided by a1, 1 divided by a2, 1 divided by a3 up to 1 divided by an, that is the reciprocals of the terms. These are in AP. Very important to note this. Then is the nth term of HP is given by 1 divided by a plus n minus 1 into d, where this a is 1 divided by a1, that is the reciprocal of the first term, and this d is taken to be as 1 divided by a2 minus 1 divided by a1. You have to take d like this. For harmonic progression, then are the results. If a and b are two non-zero numbers, then the harmonic mean of a and b is a number h such that the sequence a, h, b is a harmonic progression, and we have 1 by h to be equal to 1 divided by 2 into the sum of the reciprocals of a and b, right? Or h is equal to 2 into ab divided by a plus b. And if a1, a2, a3 up to an are n non-zero numbers, then the harmonic mean is 1 by h is equal to 1 divided by n into sum of the reciprocals of a1, a2 up to an, the sum of their reciprocals, right, divided by n. So this is all about the introduction part of the progressions. Okay, thank you. Have a nice day.